Hey everyone, I thought I was moved to a room with better lighting, but now we got a bright light behind me. But anyways, hi. So we are going to be starting day 2 of the notes, and we're going to be we're going to be continuing on with the stuff that we were doing last time. You'll see in some of these problems now we've got some different variables besides x and y, so just be careful when you're entering those values in. And then we're going to be adding on to this. We're going to be adding in another step, which is factoring out a GCF, and then going from there. So let's start off by reviewing first number one here. Let's go through the whole process again. If you recall when we're doing these, we're going to go through. Remember, let's talk about first what a, b, and c are. A is the value right here that's attached to my x squared. The b value is the number that's attached to x, and the c value is the one that's off on its own. So if we were to write this out, remember that my a is 5, my b is 13, and my c is -6. Okay? So using those values, if you go back and look at your notes from the first section, we're going to go through and multiply a and b together. I'm sorry, a and c, which means we're going to go 5 times -6. That's going to equal a -30. We're going to find the factors of -30, which are going to be 1 and 30. It was like the worst 3 ever. 30, 2 and 15, 3 and 10, 5 and 6. Now this is one that's kind of a special case because we've got 2 different ways that we can actually get a 13, because that's what we're trying to get here is a 13, and we can actually get that from these 2 right here. If I did 15 minus 2, that's going to give me a 13, and if I did 10 plus 3, that also is going to give me a 13. So the question is, which is the proper one that we need to use? Well, it comes down to the multiplication part of this. If I did 10 times 3, 10 times 3 is going to give us a positive 30, but we've got a -30 here. Okay? If we've got a 15 and a -2 and we multiply those together, we end up with a -30. So we know that it's not actually going to be this one down here, it's actually going to be the 15 minus 2. So using those values, the 15 and the -2, if you remember now, we're going to go ahead and divide by the a value, which is 5. We're going to reduce those fractions, which will give me a positive 3 and a -2 over 5 still. We write those fractions in there. So we're going to have an x, the +3 and the -2 over 5. And then we're going to finally take that 5 and we're going to swing it over. Swings over in front of the x and it becomes 5x minus 2. Okay? All right, let's continue on. This one, be careful. We got y's, so when you write your answers online, remember that there's y's involved here. And we're going to speed this up. 2 times -14 gives us -28. Factors of 28 are 1 and 28, 2 and 14, 4 and 7. We're looking for a positive 3 here, and we can only get that from 4 and 7. But the way to get this is going to be to do a 7 minus 4. So we do 7 minus 4, divide by my a value. Remember, your a value here is this 2. We're going to get 7 over 2 minus 2. When you reduce your fractions, write the factors. So we're going to have x plus 7 over 2 and x. I almost made the mistake. 9x. It's a y. It's a y in this problem. And then minus 2. And then we're going to slide the 2 over. It's going to be 2y plus 7, and then y minus 2. Okay? Take a look at number 3. Same thing. 9 times 4 equals 36. Factors of 36 and 1 are 36. 2 and 18. 3 and 12. 4 and 9. And then 6 and 6. And the only ones that will give us a positive 12 would be a 6 plus 6. So we're going to use a 6 and a 6. We're going to divide by my a value, which is a 9. We're going to reduce these fractions, which will be 2/3 and 2/3. We're going to have an x and an x. Put your 2/3 in. And then we take those 3's and we slide them over, and we end up with a 3x plus 2 and a 3x plus 2. Now I know a lot of people get tripped up by the fact that these are exactly the same. That happens. It's totally okay. This is what we actually call in the future, if you ever see this again, we call it a perfect square trinomial. Okay. And this happens whenever we get the exact same binomials down here for the same thing. There's a whole formula. We're not going to go into it right now. Maybe later we will, though. Okay? All right, let's take a look at number 4. Be careful. We got p's in this problem now, not x's. Same process. We got 3 times 8, which is 24. Factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. We are trying to get a negative 14. The only way we can get that is with that 2 and the 12. And in order to do that, we're going to have to go a negative 2 and a negative 12, because those will give me a negative 14. Let's divide by our a value, which is 3. Okay. Reduce our fractions, which this reduces. The other one, I'm sorry, negative 2 over 3 does not reduce. Negative 12 over 3 does reduce. It becomes a negative 4. We will write our factors out. We're going to have x minus 2 over 3 and x minus 4. Sweep that 3 over. We get 3x minus 2 and x minus 4. And I did it again. See, I told you guys, I fall in this trap all the time too. It's not going to be an x that we're going to use here. It's going to be a p. When you write your answers on Class Kick, you need to make sure that you use the p for that, not an x. Okay? All right, take a look at number 5. Now we're going to be solving. So this is the same thing as what we did last time. But what's going to happen is because it equals 0, we're going to actually figure out what is the value for p. So when we look at this, let's multiply 5 times negative 6. We get negative 30. That's 1 and 30, 2 and 15, 3 and 10, 5 and 6. We are trying to get a positive 7. We can only get that from 10 and 3. So we're going to go 10 minus 3 will give us 7. Divide by my a value. We get 2, negative 3 over 5. And if you recall, at this point we said let's take the shortcut to solve this. The shortcut, if you remember, is to take the opposite of each one of these values. So the opposite of a positive 2 means that we're going to have a negative 2. And the opposite of negative 3 over 5 is going to be a positive 3 over 5. And these are your two answers. I remember to get that p this time. All right, let's look at number 6. We're going to have 11 times negative 3. That's negative 33. We have 1 and 33, 3 and 11, and that's it. Not many. All right, 11 and 3 to get 8 means that we're going to have 11 minus 3. Divide by our a value, which is 11. This will reduce to 1. This will leave as a negative 3 over 11. They don't reduce. Take the shortcut, we get negative 1 and positive 3 over 11. So these are your two answers. But negative 1 and positive 3 over 11. Okay? That looks kind of like a 1. I'm going to make that more like a comma. All right, now, on number 7 and number 8, they tell us to actually factor out a greatest common factor first. Okay, and this is something we did actually in the last unit. Remember, GCF means what's the biggest number that I could divide everything by? And do they have any x's or y's or whatever the letter is that they have in common? So when we look at this, we do have a 5 in common for both of these. So if I take the 5 out, you can see when we look at this that there's two terms here. There's 1, 2. So we're going to divide each of those by a 5. And the GCF, remember, goes in front. So we're left with an x squared and a minus 9. If you remember for the difference of squares, this is that formula where we said we could tell it's the difference of squares because this is a perfect square, this is a perfect square, and it's the difference of squares. So what does it mean to be a perfect square? Remember that this is the same as saying x times x, and the 9 is the same as saying 3 times 3. So remember, it's anything times itself is a perfect square, okay? And we're going to just take those values. We're going to put an x and an x, a positive 3, a negative 3, and we're going to solve this. The 2 right here tells us that there's only 2 solutions. So let's solve for each of those solutions. Opposite of 3 is negative 3, and the opposite of negative 3 is a positive 3. Those are your two answers, 3 and -3. All right, let's take a look at number 8 and the last one for our notes here. Let's look at what they have in common. Okay, I could divide all these things by 2. Not only that, we can see that there is at least one x in each of these, right? There's 3 x's here, there's 2 here, and there's only 1 here. They each have 1. They don't each have 2. So the least that so the most that they actually have in common is just 1. Divide by 2x for each of these, and we end up with x squared remaining. These will remove just one of them. 12 divided by 2 is 6, with one of the x's still remaining. And then 16 divided by 2 is 8, with those x's canceling. And now we continue on with our factoring. We're going to look at this and figure out, this is not a difference of squares. It's not like the last problem we just did. This is just straight factoring. Factors of 8 that add up to 6. Okay? Those factors for 8 are 1 and 8, 2 and 4. 2 and 4 add up to 6. Okay? And because we have, when we look at this, there's 3 answers for this problem that we're going to solve each one of these x's. This x here is going to equal 0. This x here is going to be the opposite of that 2, which is a -2. This x here is going to be the opposite of this, which is a -4. And so my answers are 0, -2, and -4. Okay? Please let me know if you have any questions. I hope this was informative. You guys take care until we see you next time.